All right, welcome back. So today we are going to be talking about how to write numbers in scientific notation. Previously, we've discussed how to identify numbers that are written in scientific notation, but today we're going to be taking our ordinary numbers and we're going to be transforming them into scientific notation. And I'm going to offer some tips and tricks that are going to aid us within this process. So today, again, we're going to be talking about how to write a number in scientific notation. So here is the key idea of today, as well as two examples. I'm going to ask that you pause the video, jot down the notes, and then resume when you are ready to hear the notes, as well as offer some side notes for it. So if you're listening to my voice, that means you've copied down what's on the screen, and we're going to be going through it. So how to write numbers in scientific notation. Step 1, move the decimal point so it's located to the right of the leading non-zero digit. Pretty much what this says right here is place the decimal so that there's a ones digit and then the rest are decimal digits. So we're going to ones digit. And then we're going to put a decimal, and then it's going to be the 10th. Okay, so every time we write numbers in scientific notation, it's going to have a digit in the ones and then a digit in the 10th, and then all the way down. Okay, but it has to be a non-zero digit. So it can be 1, 2, 3, 4, 5, 6, 7, 8, or 9, but we do not want to have 0 point something because then that's not between 1 and 10 because our ultimate goal is to have that base be between 1 and 10. Step 2 says count the number of places you move the decimal point. This indicates the exponent of the power of 10 as shown below. Okay, so we need to then count and say, okay, how many times did I move this decimal point? That's going to be the exponent for the base of 10. So for the first example, all the way on the left-hand side, okay, number 1 says we're starting out with 8,600. And we can rewrite that as 8.6 times 10 to the third. Well, if you notice, we move the decimal place 3 times. So now our exponent is going to be positive 3. The way that I look at it, because it's kind of counterintuitive, because you see, oh, well, I moved the decimal 3 times to the left, but left is normally associated with negative values, so why isn't it negative 3? Well, here's how I look at it. When I have 8,600, I know it's going to be 8.6, because we want to have a digit in the ones and then the tenth. You can have hundredths, thousandths, so on and so forth in the decimal, but we need to have only a ones digit, and then as many decimal digits as we want. I would say, okay, how many times would I have to move the decimal to get back to 8,600? So if I have 8.6 and I want to get it to 8,600, I would have to move it 3 times. So it would theoretically be here. I have to go 1, 2, 3. So that's how we get a positive 3. Over on the right-hand side, if we have a number that's less than 1, right, so we have this 0.0024. Well, we write that as 2.4 times 10 to the negative third. And again, using the tip of mine, if I have 2.4 and I want to get it into 0.0024, I would have to move it 1, 2, 3 times to the left. And that's where we end up. So that's why we get that negative exponent, because we would have to move it 3 times to the left. That might be confusing, but let's go through some example problems. So here are 6 example problems that we're going to go through. Please pause the video, copy them down, give yourself some space, and then we're going to be working on it together. Okay, so we have number 1, 0.00034. We know that it has to have a ones digit and then a decimal digit, so on and so forth. So it's going to end up, whoa, what was that? That was crazy. This is spazzing out. Let's try that again. All right. So it's going to end up being right there between 3 and 4. So it's going to end up being 3.4 times 10 to some power. But if I wanted to get 3.4 back to where I started, well, I moved, let's see, 1, 2, 3, 4 times. So it's going to be to the negative fourth. If you want to think about negative and positive being, okay, I'm going to have a small number, it's going to be negative. If I'm going to end up with a big number, it's going to be positive. For example, in number 2, we have 6,750,000. We have to put our decimal. It's going to be right there. It's going to be between the 6 and the 7. So it's going to be 6.75. We don't need to include all of the extra zeros. That's where our times 10 to some power comes in. Well, in order to get that decimal spot, starting from here over, I had to go 1, 2, 3, 4, 5, 6 times. And notice how I'm starting out with a huge number, since 6 million, so it's going to be a positive exponent. So this is a huge number, yields a positive exponent. Okay, in our first example, we had a small number that yields a negative exponent. Let's go through the rest of the examples. So we have 0.000000007. That's a lot of zeros. This is why scientific notation is going to be very helpful. So it's going to end up being there. 7 is going to be the first non-zero digit. So it's going to be 7 point. We can put 0. If you had 7, that's fine. Times 10 to the, well, I'm starting out with a very small number, so I'm going to have a negative exponent. And now we got to count how many times do we move it. Well, the decimal starts here. Go 1, 2, 3, 4, 5, 6, 7, 8. Times 10 to the negative 8th. For number 4, we have 125,000. My decimal would have to be between the 1 and the 2, so it's going to be 1.25 times 10. And now it's going to be a positive exponent because I have a big number. So decimal starts here. I moved it 1, 2, 3, 4, 5 times. So it's going to be 1.25 times 10 to the 5th. All right, here we go. Number 5. Ooh, that's a big number. 15,200,000,000. My decimal is going to have to go between the 1 and the 5 because that's now the non-zero leading digit. And 1.52 is between 1 and 10, so it all works out. Times 10 to the, okay, I have a big number, so it's going to be a positive exponent. How many times did I have to move it? Well, I start here, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Times 10 to the 10th. And last but not least, we have this very small number. So we have 0.0000000000917. We have to end up being between 1 and 10, so it's going to be in between that 9 and the 1s. Here we go. So now we have 9.17 times 10. I have a very small number, so it's going to be a negative exponent. And now we got to count. How many times did we move it? Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 9.17 times 10 to the negative 10th. Great job, everyone. Please complete the worksheet. If you have any questions, please reach out. You're doing a great job with this. Keep your head up, stay safe, and please, please, please reach out if you have any questions. Have a good one.